This one also has a dash T after the question number that you cannot see. So they're expecting us to do this on the TI-84. I'm going to show that way and then also show what we could do using tables. Some of you may have older calculators where, besides part A, you may need to see some of that approach, even if you still can use some of what's on your calculator. Because we're looking for numbers of chips in each of these. We're working backwards from percents or proportions to go from that to what our scores were. Inverse normal on the calculator, second, distributions, third choice. And on the first one, 26th percentile means that we're going left of something with a mean of 1,261, standard deviation of 117, but we're going left of that cutoff point to get an area of 0.26. And they want this to the nearest whole number. That's going to round to 1,186 chocolate chips. The middle 95%. What I'll be showing when using tables, z-scores, and algebra to get x is outside of 95%, you will have 5% total in the tails, and so 2.5%. So either those of you with the newer TI-84s, clear this out. Inverse normal again. Newer calculators on inverse normal, we can put in that 0.95. Mu and sigma have not changed. Switch to center and then paste it, press enter. That's telling us we're going between, when we round this, 1,032 and 1,490 chips. But if I had found the left, some of the older calculators only have that. There is our lower bound. No, I'm making something different. Oh, because I said that would be the lower 2.5% or 0.025. So I need to change that. Took outside of 95% was 5. And because of the symmetry, split the tails in half and just go with the left tail. That when rounded is 1,032. To come up with the upper bound, since the mean was 1,261, I could ask how far away that score we just came up with is from the mean. And then add that result to the mean. And that will give me the upper bound of 1,490. Last, before we see the table, z-score, and then algebra to get x, interquartile range. We would want our middle 25%. 0.25. Same mu and sigma. Center now. See if they want us to round here. Nearest whole number. So we take that 1298.28 something minus 1223.7 something. I'm not sure if I can just round each of those individually. 1298 minus 1224. They may want us to subtract and then only round once. Let's see what happens. 74. Ah. I was thinking of below or above Q1 or Q3, but in between there's 50%. So 50%, 0.50 for an area. Now we can do center, paste and enter. 1340 minus 1192, 1182. It's giving me 158. And now it's happy. Okay, so what would I have had to do? 26th percentile, going below that. It's not a z-score, let alone not an x. It's the proportion that would be shaded to the left. The bottom 26% or 0.02600 shaded in here. And let's see, going to the table. Looking inside for something close to 0.600. This is 11 10,000ths apart. This is 22 10,000ths apart. So we're going with 0.8. Is that negative or positive? Negative 0.84. Okay. So 0.84 for z-score. When we had a mean of 1261 as a raw X score and a standard deviation of 117, we're going to be solving the following. Z equals X minus mu. X is unknown, but Z is known. All over sigma of 117. So multiplying 0.84 by 117. Adding 1261. See what we get on the calculator and compare it to what we had calculating this with the TI-84 instead. So that was 1261 plus 0.84 times 117. We came up with in part A. That was a negative 0.84 that I read. So I should be subtracting, instead of adding, subtract from 1261. We were were supposed to come up with something similar to what was on the TI-84, which was when rounded 1186. It is different. Just going to see what happens. You know, the table should be less exact. Go to the left, so -10 to the 99 up to whatever answer I just got. Mean was 1261. Standard deviation was 117. I should get an area to the left of the answer we just got, being around 0.26. Interesting. 0.2611. That's a negative 0.64. And if I put in that, and of course, you can't have a portion of a chip, so let me go with 1186, rounding down. 1186, 1261, and 117. That's pretty close to 0.26. Okay, the second part. Middle 95%. Let me draw a picture with what I was talking about earlier. You've got 95% in between. Then in the two tails, you've got 5%. Divide that by 2 because of symmetry, and convert 2.5% to 0.025. Your area on either side, 0.025. On the table, .025. Looks like the closest we're going to get is with a negative 0.67. So, on the other hand, z-scores versus x's, if you change the sign, you're going to get quartile 3. Let's see what happens. It's the same calculation we had up here, up 0.67 with a negative. That has me going, if I round that to 1159 for an X score, a number of chips. And if I switch that to addition, $13.63. They were asking for the boundaries there, so 1032, 1063. I'm way off. 5%, 2.5%, 0.025. That's my mistake. 0.025, not 0.25. That's going to be closest to negative 1.96, it looks like. Yes. So the upper bound, positive 1.96. Okay. Watch out for stuff like that. When you convert to a decimal, sometimes you do need that 0 between the decimal point and your first non-zero. So negative 1.96. positive 0.96. Comparing to what we came up with inverse normal, 1032 to 1490 after rounding. And the last part, what's the interquartile range? Now I am looking for 0.25. So those numbers I just had with that wrong z-score, I'd be taking this minus this, and that would round to 204. Again, I seem to be way off. Let's double check. So looking up 0.25. I was closer to negative 0.67. So let's do this. Might have had a 0.87 in there accidentally. That's going to give us the lower bound. The upper bound would have addition. So I'm going to put parentheses around the upper bound minus the lower bound without actually calculating what they are. See if I'm any closer that time. So 1261 plus 0.67 times 117 minus 1261 minus parentheses around all of that is more important. 0.67 times 117. That's going to round to 157. Their answer was 158 when we used inverse normal. And that's good. Okay.